Hey guys, this video is on the data cycle and circle graphs. So this is the data cycle, and it is a process that we follow that begins with a question. So any type of question that you might have, a wonder, something like, I wonder what kind of music my students like listening to. That is a question. And I start with a question, and what am I going to do with that? Either I can wonder that forever, or maybe I'll go and poll my students on what kind of music they like listening to. So the next step on the data cycle is to collect that data, is to get that information, maybe sending out a survey, maybe just asking people whatever your question is. We get that information. And what do we do once we have all the information? We can organize it in a table, a frequency table, a circle graph, a histogram, some sort of graph, so that we can easily read the data. Once we've organized it and put it on some kind of graph, we can read it, we can analyze it, and figure out what the results are. Turns out a lot of my students like listening to rap and R&B, or my students, maybe that's the most popular, but second up is pop music. And then maybe that could lead to another question. Well, I wonder what types of, what are the pop music artists that you guys like listening to? And then it starts this data cycle over again. So it starts with a question, a wonder. Then let's go get that information. Let's organize that information, and then let's read it and come up with some sort of conclusion about it. That is the data cycle. Here are 3 questions about the data cycle. Good thing about a video is you can always pause the video and try to answer these questions on your own and get yourself thinking about these things before I go over it. So now's a good time to pause this video, try to answer the questions. But I'll go ahead and start with this first question. What is data or data? It is information. We collect data when we ask questions. The data cycle begins with a question. So what is your favorite type of music? All the different types of music you guys say, and how many people say country, how many people say indie. That is data. That is the information. My classic example that I talk about a lot in class is YouTube. YouTube collects all kinds of data. It collects the amount of time people spend watching videos. It collects data on how many views and likes and comments there are. It also collects information on what types of videos you guys like watching. So if you're watching gaming videos, it's going to suggest other gaming videos for you to watch. So it's collecting all of this information. That is what data is. It is information. What is the difference between numerical and categorical data? These are the 2 types of data we explored in class. In fact, any type of question you've ever answered in your life is either numerical or categorical. Numerical is data in the form of numbers. For example, how old are you? What time did you wake up? How often do you go out to eat? Categorical is data in the form of words. So what is your favorite color? What is your favorite type of music? What is your pet's names? And then the last question here is, what is the difference between population and sample? Population is who you are interested in, that you are questioning. So if, again, I wanted to know about my students, or maybe all students at HVA, and what type of music they like listening to, that is my population, HVA students. Now, I don't always have time to ask everybody. So our sample is who we're going to ask our question to, who's actually going to answer this question to represent the entire population. You can think about this like in social studies. We have delegates that represent county, states, right? We have, if you have a trial game, you go to Target and you're playing a game, you get to sample the game. You don't get to play the whole game because they want you to buy it. But a sample is just a little taste of that population. And the most important part about your sample is it has to be random. Okay, I can't only choose like the high scoring students and what kind of music they like listening to. It's got to include everybody, or it's not fair. It's got to be random, include everybody. If I wanted to know about people in the state of Virginia, I'm not only going to ask people who live in Richmond, because what about all the other cities in the state of Virginia? All right, so that is the data cycle. Moving on now to circle graphs, pie charts. They're the same thing. It is used to compare a few categories, and it is convenient because it is easy to think about these percentages. So we are not going to use a circle graph if we have a lot of categories. This is one of the cons. Remember, we're only going to use a graph that makes the most sense, that makes it easy to read and easiest for us to draw conclusions from. So we probably wouldn't use a circle graph for something like this. But when there's a few categories, it's really easy to see those percentages. I know this blue section is almost half of the circle. It's really easy to see. This is one of the pros of a circle graph. Let's do some practice here. What is the total percentage of a circle graph? The entire thing, the whole thing, is 100%. So if you're missing a portion of your circle graph, we're missing this blue section. If I have all the other ones, well, I know the sum should be 100. We are allowed to use our calculator here. So I put in my calculator 100 minus the green, the orange, and the red section. So what I have left is the blue, which is 48%. Which looks pretty accurate. This is almost half of my circle. Half of your circle is 50%. What is the total percentage of this circle graph? Still 100. Here's another one. We're missing this category. Now's a good time to pause this video and see if you can figure it out. If the total is 100, I'm going to start with 100 in my calculator, and I'm going to subtract history, literature, Spanish, and science. And what I'm left with is 24% for math, which also looks pretty accurate. That's almost a quarter of the circle. Estimation. The good part about a circle graph that you can't do with a bar graph or a histogram is to estimate your percentage. It's very easy to cut your circle in half, either long vertically or horizontally, and see what that halfway point is. We know that half is 50%. If your phone is half charged, it's 50%. Quarters are also a pretty standard estimation here. A quarter is worth 25 cents. That is 25%. So what percentage is the red section? The red is exactly a quarter. About what percentage is purple and blue? There's no way to know for sure, but we can have a good estimation. Purple and blue is almost 50%. Not quite the whole half because we have this little slither of green coming through. So we know it's over a quarter, almost 2 quarters, almost a half. A good estimation would be about 40%, maybe 45%. Let's do another estimation. About what percentage is this brown section right here, this kind of brownish green? If we cut our circle in halves and quarters again, you can see, well, it's not quite a full quarter. It looks like a little bit more than half of a quarter. Maybe like 15%. What percentage is purple, blue, green, and brown? So that's right here. Purple, blue, green, and brown all the way, almost all the way around. We know it's definitely more than half of that circle. In fact, it's 3/4 of the circle, and 3/4 is 75 cents, 75%. And again, this is something that you cannot estimate well with a bar graph. So this is one of the pros of a circle graph. Okay. If 100 people were surveyed, how many chose surfing? Surfing's right here. This is purple. Again, is another good time for you to pause this video and try to answer these questions yourself. If 100 people were surveyed, 15% chose surfing, and percentage is already out of 100. So conveniently, if you're asking 100 people, that percentage does tell you the number of total people, but that only works if it's out of 100. So if we have 200 people, it's not 15 people who chose surfing. It's double the amount. This one's going to be 30 people. If we ask more people are probably going to choose surfing as well. You can do this in the calculator. Here's how we would do it in the calculator. If 350 people were surveyed, how many chose movie watching? Okay, this one's a different question. This is movie watching right here in yellow. 4% chose movie watching. We need to figure out what is 4% of 350. It's not 4 people, okay? This percentage doesn't tell us how many people. It's 4% of our total. We asked 350. That's going to be 14. And look how I typed it into Desmos. What is 4% of 350? 14. So 14 people out of the entire 350 chose movie watching. Which is pretty surprising if you ask me. I feel like a lot of people like watching movies. Okay, if 280 people were surveyed, how many chose surfing? We're going back to surfing. Surfing, remember, is that 15%. So we're going to type into Desmos 15% of 280. And we get 42. So 42 people chose surfing out of 280. Not 15, but 42. Okay, use Desmos. I think this is the last bit. Last bit, circle graph versus a bar graph. Sometimes we use multiple types of graphs to show our data. Some are easier to read than others. But it should match, okay? So if you have this pie chart, the circle graph, and you see that the largest chunk is romance, on your bar graph, that should also be your largest, your tallest bar. Now, looking at the bar graph, it's hard to know that that's 35%. We could probably estimate that better on the circle graph, right? Using our half and quarter strategy here. But I just wanted to note that the largest bar would be the largest slice. The smallest bar will be the smallest slice. All right, guys, I hope that helps. Hopefully that was a good recap of the data cycle and circle graphs.